Hello children, so we'll continue with trigonometry. Now today we'll see that these trigonometric functions are periodic functions. Okay, now let's try to understand what we mean by periodic function. Now if f of x plus p is equal to f of x, where p is a real number and x is domain of the function, x is domain of a function, then it is called periodic function. Now domain means all those values of x which for which f of x, x plus p is defined. For example, now this way maybe it's not clear. Let's take example. Okay, sin x. Okay, sin x is a function, trigonometric functions. So all those values which x can take, for which sin x is defined, is called domain of x. Okay, that's called domain of function. This is domain of f, that is all those values of x for which sin x is defined is called domain of the function sin x. All right, so here you see, let's take a circle here, it will be easier to understand. Okay, this is x, this is O, this is y-axis. Okay, this is x and y-axis. Suppose here this angle is x. Okay, now sin x plus 0, where value p is 0. Sin x plus 0 is obviously it is sin x only. Okay, no problem. Suppose it rotates this point. Okay, this line rotates once completely, it starts from here. Okay, it rotates and comes back here once again, the same position here. Then this value from here to here, you know, angle is 2 pi, and this will be x here. So it will be, this is 2 pi, this is x. So here sin x plus 2 pi will also be equal to sin x, because it will be the same angle here. You see, when you add 2 pi here, this is 2 pi. Okay, plus up to here it is 2 pi because 360 degree, then x here. So 2 pi plus x also will be the same angle here. So the value should be same. Similarly, sin x plus 2 into 2 pi also will be sin x, because if it rotates twice, then comes back here, then also here 2 pi, this is 2 pi. So 2 into 2 pi, then this is x again. So again this is sin x. So when you take x plus 0, x plus 2 pi, x plus 2 into 2 pi, it is sin x only. So these are called periodic functions. So same is true with all other functions. So you see now, from here, sin x plus 2 pi is equal to sin x. Similarly, cos x plus 2 pi is also cos x, and tan x plus 2 pi is also tan x. Okay, so if you take the multiple of 2 pi, then the value of these ratios will remain same. So as you can see, when you take 2 pi means one rotation, then if you take 2 rotations, you get 2 into 2 pi. If you take 3 rotations, you get 3 into 3 pi. So you can generalize now. So sin x plus n into 2 pi will also be sin x, where n belongs to z, any integer, positive or negative. When n equal to 0, you get sin x equal to sin x. When n equal to 1, you get sin x plus 2 pi equals sin x. When n equal to 2, you get x plus 2 into 2 pi is also sin x. Similarly, cos x plus n into 2 pi you also will be cos x, same is. Okay, so any multiple of 2 pi, if you take any multiple of 2 pi plus x, the value will be same as sin x. Okay, this is called periodic. That's why these functions are called periodic functions. So remember that. Now another important thing is the signs of t functions. Okay, So here take origin, this is x-axis, this is y-axis. Okay, if circle is divided into 4 quadrants here, this is x dash and this is y dash. This quadrant is called first quadrant, this is called second quadrant. We go in anti-clockwise starting with OX. This is the initial line. This quadrant is called the third quadrant and this quadrant is called fourth quadrant. Okay. Now in different quadrants, what will be the sign of this trigonometric ratio? That's what we are trying to find out. Okay. So suppose you take any point P here, AB. Okay. So obviously, if you take a perpendicular from this one, this is A, this is B. Now this is X here. Okay. Now in this quadrant, A is positive, B is positive, and this hypotenuse is always positive. Okay. If we take this as R, then R is always positive. So you see, since all three sides are positive, all trigonometric ratios will be positive. There is no question of getting any negative sign. So in this quadrant, all ratios are positive. Okay, means sign is positive, cos, tan, cos x, sec, cot, all ratios are positive because all three sides are positive. Now if you take that point here on the second quadrant, obviously you see this A will be negative minus A, this will be positive B, because this is on the negative side of x-axis, this is the origin, on this side is negative. Now all the ratios, R is always positive no matter where it is. Now all the ratios involving minus sign, this is this side, okay, minus A will be negative. If this is x, then this will be perpendicular, this will be hypotenuse, this will be base. So all the ratios involving base will be negative. Okay. So ratio involving base is cos. Cos is b by h. So here only those ratios, see, containing these two will be positive, rest all will be negative. Okay, so ratios containing these two will be positive. That is, one is p by h, other one is s by p. Only those two will be negative. Remaining ratios will be negative. This by this will be negative. This by this also negative. This by this also will be negative. So only two ratios will be positive. The ratio which involve perpendicular and hypotenuse. So these ratios are sine and is reciprocal cos x. These are positive because sine is p by h. So both are positive. Cos x is s by p. Both are positive. Rest of the ratios contain minus a, so they are all negative. Okay. So similarly, if you take the point here on the third quadrant, so this is minus a, this is also minus b. This is always positive. So if you take the ratio of these two, will be negative. Ratio of these two will also be negative. But ratios involving these two will be positive because minus sign will get cancelled. So P and B. So ratio involving these is tan. Tan is turn permanently black, and cot is B by P. So these two ratios are positive. Remaining all ratios are negative. Okay. Similarly, in the fourth quadrant, suppose here this A is positive but B will be negative. So this R is always positive. So ratio involving these two will be positive. Ratio involving this will be negative. So B by S, this is X here. So here it is the ratios involving base and hypotenuse, that is cos. So cos and reciprocal sec will be positive. Okay, remaining all negative. So here all positive, here sine and reciprocal cosec positive, here tan and cot positive, here sec, cos and sec positive. Okay, how to remember this sign rule now? Okay, so just remember, add sugar to coffee. This is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. Okay, add means all ratios. A stands for all. Sugar stands for sine and is reciprocal cosec. 2 stands for tan and reciprocal cot. And coffee, C stands for cos and reciprocal, that is sec. So add sugar to coffee. Add sugar to coffee. That way you remember the sign. Okay. So suppose you have to find the value of sine 200 degree. So whether this will be positive or negative, how do you know? You have to find out which quadrant this angle lies in. Then you can find the sign. So this is 0 degree, this is 90 degree, that is pi by 2. This is 180 degree, equivalent to pi. This is 270 degree, that is 3 pi by 2, and 360 degree will be 2 pi. Okay. So we are moving, rotation is in this direction. If it rotates in this direction, it will be negative. Okay. So 0 to 90 will lie in this quadrant. 90, more than 90 up to 180 will lie in this quadrant. More than 180, less than 270 will be here, and 270, more than 270 and less than 360 will be in the fourth quadrant. So 200 lies between 180 and 270. So it lies in the third quadrant. And third quadrant sign is negative, so this value will be negative. Okay. So this way we can find out the quadrant in which this angle lies. Then we can choose the appropriate sign, whether it will be positive or negative. Okay. So that is called sign rule. Now next concept comes domain and range of the functions. Okay. Domain, I told you, all those values of x for which the function is defined. Suppose you have f of x is equal to sine x. Okay. Now no matter what value you take, x is in radian measure. Okay, sine x, x is radian measure. So no matter what you take, f of x is always defined. Means it won't be infinite. So here domain is x belongs to R. So any real number can be taken for which f of x is defined. So domain of sine x is what? It is real number. Okay, cos also same thing. F of x equal to suppose cos x. Cos x also defined for all the values of x. X can be any real number. F of x always defined. Never it is infinity. Okay, so for this also domain is real number. Okay, so if you see for sine and cos, domain is all real numbers. But for tan and sec, all real numbers except 2n plus 1 pi by 2. Remember, except 2n plus 1 pi by 2. Because for these values, tan and sec are not defined. The values will be infinity. For example, suppose n equal to 0. Then 2 into 0 will be 0, 0 plus 1 will be 1, 1 into pi by 2 will be pi by 2. Now you know what is tan pi by 2. Pi by 2 means 90 degree, tan 90 degree what? Infinity. Infinity means what? It is undefined. So when x takes this value, any of the values here, tan of this value will be undefined. That means x cannot take these values for all n belongs to z. So any value of n belongs to z. This for this value tan and sec are not defined. The values will be infinity. Okay, when n equal to 0 you saw tan 90 is infinity. When n equal to 1, so this will be 2 ones are 2 plus 1 3, 3 pi by 2. 3 pi by 2 is 270 degree, 270, and that is also undefined. For 270 also it is undefined. So with sec. So for these values of x, tan and sec are infinity, undefined. So x cannot take these values, but except these values it can take any other real value. Okay, so domain for tan and sec is what? Any real number except this one. Okay, where n belongs to z. Now similarly for cot and cosec, any real number except n pi. Because you know, when n equal to 0, you know, cot 0 equals what? Infinity. Because cot 90 is tan 90 is infinity, and tan 0 is 0. So you know, tan 0 equal to 0. So cot is reciprocal. So cot 0 will be 1 by 0, that is infinity, because cot is 1 by tan. So 1 by tan, infinity. So when n equal to 1, so cot pi also infinity. So for any n belongs to z, okay, so these values of cot and cosec will be infinity. So it's not defined. So x cannot take those values. So x can take any value, any real number except n pi. Okay. So you see, domain means those values of x which can be taken for which the given function is defined, means the value is not infinity. Okay. Now range. Okay. Range means what? Range means, suppose f of x equal to sine x. Now remember, all the values that x can take, that is called domain of f. We write d subscript f. Okay, domain of f. Alright, so all those values which x can take, that domain of f. For those values of x, the values of f of x is called range. Values of x are called domain. Values of f of x called range. You see, now you know sine 0 is 0, okay, and sine 90 pi by 2 is equal to 1. Okay, so you see, then sine 180, sine pi equal to again 0, then sine 3 pi by 2 is equal to minus 1. If you look at the graph here for sine, this is 0, this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, and so on. Sine 0 is 0, so this is plus 1, this is minus 1. So sine 0 is 0, sine pi is 1, then 0, then minus 1, then 0, then this way. So for any value of x, these are the values of x. Okay, any value of x, the value of sine x lies between 1 and minus 1 only. You can't get the value less than minus 1 or more than 1. So you take any value of x, the value of sine x is always between 1 and minus 1 only. Okay, so range of this function. So if f of x equal to sine x, then range of f equal to minus 1 to 1 only. This, now meaning of this is closed bracket. This means minus 1 less than equal to f of x. Okay, f of x less than equal to 1. This bracket means this one. If you take open interval minus 1 1, it means minus 1 less than x less than 1. Okay, here is not equal to. This means, okay, f of x can take minus 1 and 1 also, and any value between these two. Here x can take any value between minus 1 and 1, but not minus 1 and 1. That is the difference. Okay, so for cos also same thing. You take any value of x, value of cos x is always between minus 1 and 1 only. Okay, tan goes to plus infinity and goes to minus infinity. Cot also same thing. So you can take any real value. So range is any real value. Sec and cosec, no, the value of sec and cosec is always either less than minus 1 or more than 1. You cannot get the value between minus 1 and 1. That's why range of x, suppose f of x equal to you have sec x, then range of f will be, it is from minus infinity to minus 1. Okay, then union, it will be 1 to plus infinity, except these values. Okay, so value of this function will be less than minus 1 or more than 1. That's why we say except this. So you have to remember range of sine cos is -1 to 1, close bracket, including -1 to 1. Tan and cot, it's any real number. For second cosec, any real number except interval -1 to 1, meaning the value should be either less than -1 or more than 1. Value of sec x will be either less than -1 or more than 1. So that's why the range is union of these two, -infinity to -1, then 1 to infinity. So between -1 and 1 there is no value. Okay, so now let's take a few questions. Okay, number 1, given f of x equal to 1 upon 3 minus 2 sine x. Question says find the domain of this function. Okay, so domain of this function means the value of x, okay, which for which f of x is defined. Okay, now if you see, if denominator is 0, then 1 by 0 will be undefined. So any value that makes denominator 0, for that value of x, f of x is not defined. Okay, so since f of x is defined, okay, this 3 minus 2 sine x should not be equal to 0, because if this is equal to 0, then f of x is not defined. Okay, f of function is not defined, so x cannot take that value. Okay, so this means 3 should not be equal to 2 sine x, taking 2 sine x to the other side. This means sine x should not be equal to 3 by 2. Okay, that means sine x should not be equal to 1 by 2, 1.5. And you know the range of, but sine x belongs to -1 to 1 only. The value of sine x lies between -1 and 1, so it cannot be equal to -1. So therefore that means x can take any value. Okay, so therefore domain of f is equal to any real number. Okay, any real number. For you can take any real number, f of x is always defined, because if it is not defined, then denominator has to be 0. In that case, sine x will be equal to 1.5, which is not true. Okay, so if sine x is 3 by 2, then only this is 0, but sine x cannot be 3 by 2. So that means this denominator can never be 0 for any value of x. That means x can take any real number, right? So domain of f is any real number, right? Now next, to find the range, number 2, given f of x is equal to 2 minus 3 cos x. Okay, 2 minus 3 cos x. We have to find out the range of 2 minus 3 cos x. Now you know range of cos x is -1 to 1. We have already defined this one. Range of sine and cos is -1 to 1. That means we know, okay, this cos x lies between -1 to +1 then, because that is the range of cos x. The value of cos x lies between -1 to 1. Okay, this implies now to get 3 cos x, we multiply everything by 3. So you get -3 less than equal to 3 cos x less than equal to 3. That means 3 cos x lies between -3 to +3. Okay, so now if you change the sign here, everything, so sign will change. This inequality sign will change. That means 3 greater than equal to -3 cos x greater than equal to -3. Okay, because when you change the sign, if you divide by minus sign, this inequality sign will change. Now if you to get this 2, if you add 2 to all the numbers here, then what you get? 3 plus 2 greater than equal to 2 plus 3 cos x greater than equal to minus 3 plus 2. That means 5 greater than equal to 2, minus 3 cos x greater than equal to minus 1. Minus 3 plus 2 will be minus 1. That means if you write it in less than equal to form, so minus 1 less than equal to 5, 2 minus 3 cos x less than equal to 5. So therefore range of f will be what? From minus 1 to I. So this will be range of f. Okay, so this value, for any value of x, the value of this one will lie between minus 1 and 5, including these two. Okay, now the last question for today, number 3, but it has 3 parts. So part 1, given tan 25 pi by 4. We have to find the value of tan 25 pi by 4. Okay, so how to find the value? 25 pi by 4. You know pi 180 degree, but you can't use calculator here. So you can write this as tan. If you divide 25 by 4, it will go 6 times. So you can express in mixed fractions. So 6 pi plus pi by 4. If you combine, you get this one. See, 4 into 6 pi will be 24 pi, plus pi will be 25 pi. Okay, so tan, this you can write in terms of 2 pi, that is 3 into 2 pi plus pi by 4. Now we have already seen earlier tan x plus n into 2 pi equal to tan x, isn't it? So this formula we have seen. So here n equal to 3, so this is x. That means this portion can be removed. So it will be tan x equal to tan x. So this will be equal to tan, this portion will be removed, so it will be pi by 4. Okay, so tan pi by 4 means 45 degree. So tan 45 degree, answer is 1. So this is how we find the value of the angle which is more than 2 pi. Now next question, part 2. Part 2 is given cot of minus 7 pi by 4. If it is negative, then how to do it? So you can also express this in terms of mixed fraction in terms of 2 pi. That is, cot you can write minus 2 pi plus pi by 4, because 4 2s are 8, minus 8 pi plus pi will give you minus 7 pi. Okay, you see, if you take LCM, 4 2s are 8. So minus 8 pi plus pi will give you minus 7 pi. So this also you can write as cot into cot of, you can write cot minus 1 into 2 pi plus pi by 4. You can express in standard form. Okay, cot n into 2 pi plus x form. So this portion can be removed because it's a periodic function. So this is equivalent to cot pi by 4. Cot pi by 4 is also 1. Okay, because pi by 4 means 45 degree, cot 45 degree, the answer is 1. Alright, these are in terms of pi. Now let's take part 3 where degree is given. So you have to find the value of sine 765 degree. Okay, so 765 degree. So you can write in terms of 2 pi, 360 that is. So you can write this as sine 360 into 2 is how much? 720. So you can write as 2 into 360 degree plus 2 into 360 is 720. 720 plus 45 degree is 65. Okay, if you simplify, you get 765. So this also you can write as sine 2 into 2 pi plus 45 degree. So 2 into 2 pi, periodic function. So this is equal to sine 45 degree. Sine 45 degree is 1 by root 2. So that is the answer. Okay. So we'll continue in the next class.